Breaking news. At 04:19 UTC this morning, while most of the world slept, a quiet alert echoed through mission control centers on 3 continents. A routine data downlink from the Hubble Space Telescope, an instrument that has stared into the cosmos for more than 3 decades, contained something no one was prepared to see. Moments later, confirmation arrived from a secondary analysis node in Darmstadt, Germany, followed by an urgent call between Washington and Madrid. Today, the impossible just happened. An object we believed we understood, an interstellar visitor we thought was already categorized, behaved in a way that rewrote every assumption overnight. This changes everything we thought we knew about 3I Atlas. If you want real-time updates on the most important cosmic discoveries unfolding right now, make sure to like this video, subscribe to the channel, and stay with us, because what Hubble just found is only the beginning. For months, the story of 3I Atlas seemed settled. Detected, tracked, modeled, and archived. Another interstellar object passing briefly through our solar system, cataloged alongside its predecessors, its mysteries neatly wrapped in equations and probability curves. But science has a way of humbling us, and today that confidence collapsed, because buried inside Hubble's latest ultraviolet and visible light spectra was a signal so precise, so controlled, that multiple teams independently reached the same conclusion within minutes. Everyone was wrong. Before we go any further, we need to establish how we know this. NASA's Goddard Space Flight Center initiated the original observation request. The European Space Agency coordinated parallel tracking through the European Space Network, linking dishes in Spain, Australia, and Argentina. Harvard's Center for Astrophysics and Caltech's Jet Propulsion Laboratory were looped in for independent verification. On the ground, the Atacama Large Millimeter Array in Chile pivoted its antennas within hours, while follow-up infrared observations were scheduled using the James Webb Space Telescope. This was not a single telescope anomaly. This was a global, multi-instrument, multi-continent confirmation, and all of it pointed to the same unsettling truth. 48 hours before the event, 3I Atlas was behaving exactly as predicted. Its velocity relative to the Sun measured 42.6 kilometers per second, well within the expected range for an interstellar object on a hyperbolic trajectory. Its distance stood at 2.14 astronomical units, just beyond the orbit of Mars. Spectral analysis showed a familiar mix of carbon compounds, trace water ice, and dust, nothing extraordinary. 11 hours later, however, subtle discrepancies began to appear, not enough to trigger alarms, but enough to raise eyebrows. The object's acceleration increased by 0.08 meters per second squared without any corresponding outgassing signature. No coma brightening, no thermal spike, just acceleration. 6 hours after that, Hubble recorded a shift in reflectivity. The albedo changed by nearly 12% in under 90 minutes. Natural processes do not do this. Cometary surfaces evolve, but slowly. Asteroids weather over millennia, not hours. Yet 3I Atlas was changing in real time. At 0207 UTC, its color index shifted toward shorter wavelengths, producing a faint bluish tint that had not been present in any previous observation. Then, at 0352 UTC, the motion stopped making sense entirely. According to every gravitational model we have, 3I Atlas should have continued accelerating as it fell deeper into the Sun's gravity well. Instead, its velocity plateaued, not slowed, stabilized. Precisely, within a margin of error of less than 3%. No known natural process can regulate motion with that level of control in interplanetary space. Radiation pressure is too weak, outgassing is chaotic, gravitational interactions leave signatures. This left nothing. The first internal message circulated with a simple line: recheck assumptions. Within minutes, simulation teams at Caltech reran their models. Gravitational perturbations from Jupiter ruled out. Interaction with solar wind insufficient by orders of magnitude. Thermal recoil, the temperature measured at the object's surface was approximately 210 Kelvin, far too low. One senior analyst wrote back a single sentence: "Physics does not allow this." As data continued to stream in, the anomalies multiplied. Hubble's fine guidance sensors detected a periodic fluctuation in brightness, one pulse every 37.2 seconds, then again and again, perfectly regular. When the data was overlaid with a frequency analysis, the pattern became impossible to ignore. Prime intervals, not random, not noise, a deliberate sequence. At this point, the investigation fractured into two camps. The first group, led by Dr. Elaine Mercer at NASA, argued for an extreme but natural explanation. Perhaps 3I Atlas was a fragment of a larger interstellar body with an exotic internal structure, a hydrogen-rich lattice capable of producing anisotropic outgassing without visible plumes. Simulations were run. Computational fluid dynamics models were pushed beyond their usual limits, but every scenario failed to reproduce the observed symmetry. Nature is messy. This was not. The second group, quieter at first, proposed something more radical. Dr. Anton Reyes at Harvard raised the possibility of non-gravitational propulsion. Not rockets, not engines, but something akin to a controlled mass distribution or field interaction, unknown physics or technology. Internal emails show fierce debate. Words like speculative and dangerous were used, but the data refused to cooperate with caution. Then came the escalation. At 14 hours after the initial anomaly, a fragment appeared, or rather, it didn't. Hubble recorded a secondary object separating from 3I Atlas, drifting outward at a relative velocity of 0.9 kilometers per second. 37 minutes later, it vanished. Not faded, not occluded, gone. Every sensor, optical, infrared, radio, went silent. The probability of a natural explanation dropped again. Simultaneously, Earth felt something subtle. Satellites in low Earth orbit reported brief communication dropouts, not failures, delays. Atomic clocks showed nanosecond-level discrepancies, insignificant on their own, terrifying in aggregate. Magnetometers recorded fluctuations of up to 12 nanotesla in regions with no geomagnetic storms. Birds altered migration paths. Aviation authorities logged unexplained compass deviations. Inside control rooms, the mood shifted from curiosity to restraint. Conversations moved off recorded channels. Encryption protocols were activated. ESA postponed a scheduled press briefing without explanation. NASA released a single sentence: "We are reviewing new data." That silence spoke volumes. As I stared at the combined data feed, one thought kept returning. This was no longer random. It was responding. The pulses changed. The interval adjusted. 37.2 seconds became 29, then 17. A countdown or adaptation? Spectral lines showed transient emissions in bands associated with highly ordered energy states. The object began to align, not toward the Sun, not along its original trajectory, but subtly toward Earth's orbital plane. A difference of just 0.4 degrees, enough to notice, too precise to ignore. Philosophers like to ask when we would know if we were no longer alone. The assumption is that it would be loud, obvious, dramatic. But what if intelligence announces itself quietly, through restraint, through precision? In emergency meetings, policymakers asked the same question in different words: is this a threat? The scientists could not answer. There was no weapon signature, no aggressive maneuver, just observation, just control. As the days passed, one final Hubble observation arrived. Deep ultraviolet imaging revealed a structure, faint, symmetrical, extending tens of kilometers beyond the visible object. Not a tail, a framework, ordered, mathematical, the kind of geometry that physics alone struggles to produce without guidance. I found myself thinking not of invasion, but of recognition. Maybe we're not witnessing the end, but an invitation, or maybe a test, a probe designed not to conquer, but to measure, to see how a young civilization responds when its assumptions collapse. Tonight, 3I Atlas continues its silent journey.
Its trajectory remains stable. Its pulses persist. Governments say little. Scientists argue quietly. And the rest of humanity looks up, unaware that something ancient and precise has passed through our neighborhood and refused to behave like a rock. The last data packet from Hubble ended with an unresolved anomaly, a shift so small it almost escaped notice. Almost. A change in orientation, a correction, as if the object noticed it was being watched. So the question is no longer what 3i Atlas is. The question is this: what happens when it decides to move again? Subscribe to follow the next update. The story isn't over.